All right, so I'm basically recording this lesson because I guess I can only spend a certain amount of time on this lesson, and I know some of you are absent, might be a little bit lost with this. But anyway, I'm gonna go over it. So this is section 9.3. So this is setting up a real-world problem with a rational equation. So our goal is just to write a rational equation to model a real-life problem. So here's the word problem. So it says Kevin can clean a large aquarium tank in about 7 hours. So I'm just going to underline some important information. Large tank in 7 hours. And this is Kevin. So when Kevin and Lara work together, they can clean the tank in 4 hours. Okay, so there's one tank in 4 hours. Set up a rational equation to determine how long it would take Lara to clean the tank if she works by herself. So we're trying to figure out how long it would take Lara to clean one tank if she works by herself. Okay, so let's look at some of this information. I tried to scaffold it as much as I could for you for this. So the answer will be how long it would take Lara to clean the tank if she works by herself. Okay. Kevin spends 7 hours. So Kevin spends 7 hours cleaning one tank. Kevin and Lara spend 4 hours cleaning one tank. Okay. Lara spends okay, so this is what we're trying to find out. We're trying to figure out how long it takes Lara to clean the tank. So let's call it a variable. Lara spends T hours. We don't know how many hours she takes to clean one tank. So that's our variable that we're essentially setting up to solve for. Okay. So when we're formulating this plan, so we're letting T represent the time it takes Lara to clean the tank if she works by herself. That's what we did here. Okay. Now what we want to do is we want to convert everything to an hourly rate. And by doing that, we can actually set up an equation and solve. Okay, so Kevin can clean a certain amount of the tank in 1 hour. So think about it. If he spends 7 hours cleaning one tank, he can clean 1/7 of the tank in 1 hour. Now, if Kevin and Lara work together, it says they can clean the tank in 4 hours. So what that implies is that they can clean 1/4 of the tank in 1 hour. Lara, now this one is a little bit tricky, so if you think of it this way, Lara can clean 1/T of the tank in 1 hour because we don't know how many hours she spends to clean the tank. So you just kind of look at the pattern. We just do 1/, whatever number that you see there. So Lara can clean 1/, a certain amount of time of the tank in 1 hour. Now this variable time is restricted such that the time is going to be greater than 0 hours. Okay. So what that means is that yeah, so time has to be greater than 0. Okay. Now let's try to complete the table. Okay, so what we have here, so it's we have a formula. So we have work equals rate times time. Okay. So let's look at this. So Kevin can clean a large tank. So Kevin can clean a large tank in 7 hours. So if you consider how many tanks he's working on one tank in 7 hours. Lara is working on one tank, but we don't know how many hours she's working on it. Now, if Kevin and Lara work together on one tank, it takes them 4 hours. Okay. Now, essentially, this rate, what we did was we found a whole bunch of rates here. That's essentially what goes here. So, one way to do that also is we can just manipulate this equation. So, work equals rate times time. Now, if I were to solve for the rate, I'm dividing all of this by time. Time cancels out. We get rate equals work divided by time. Right? So this rate that we're doing is work divided by time, which means that Kevin cleans 1/7 of the tank in 1 hour. Lara will clean 1/t of the tank in 1 hour. Kevin and Lara will clean 1/4 of the tank in 1 hour. So that's what we're doing with this rate. We're just doing work divided by time. And that's how we get this, this, and this. Now we can use the results from the table to write an equation. Okay, so we have rate of Kevin plus rate of Lara plus equals the total rate of Kevin and Lara. So what we're going to consider is we need to consider all of this right here. Okay, so rate of Kevin is going to be 1/7. The rate of Lara is going to be 1/t. The rate that Kevin and Lara will take to if they work together will be 1/4. Okay, rate of Kevin, rate of Lara, total rate of Kevin and Lara. And that is how you would set up a rational equation to determine how long it would take Lara to clean the tank if she works by herself. And in this case, that would be T if you had to solve for T. Okay, so that's just setting it up. Now let's try these two other examples. Okay, Jake can mulch a garden in 30 minutes. So mulch a garden in 30 minutes. Jake and Ross can mulch the same garden in 16 minutes. Set up a rational equation that determines how long it would take Ross. So we're trying to figure out how long Ross would take to mulch a garden if he works alone. So let's go ahead and create that table. So we know that work equals rate times time. Now, if I were to create this nice little table, what I see here is, I'm just going to create some things just to help you guys out. Okay, so Jake is going to go here. So, and then Jake and Ross will go here. Oh, sorry, my bad. Jake and Ross goes below. Ross goes here. And Jake and Ross will go here. Okay, so what we're doing here is instead of tanks, we're considering gardens. So our units here would be gardens, right? The rate, the time that it takes would be minutes, and the rate that we're considering is gardens divided by minutes, right? So Jake can mulch one garden in 30 minutes. Jake and Ross can mulch the same garden, so one garden in 16 minutes. So we need to set up a rational equation that determines how long it will take Ross to mulch the garden when working alone. So what this means is we don't know how long it takes Ross to mulch the garden. Since we don't know how long it takes him, we know that he's going to mulch one garden, but we don't know how long he's going to take. That's our variable, that's T. Okay, in order to find the rate, we do exactly what we did here. So we use this formula, work divided by time. So work divided by time, this is 1/30. This Ross's rate is going to be 1/t. And their total rate is going to be 1 divided by 16. Okay, so if I were to create an equation based off the rates, we're doing 1 over 30 plus 1 over t equals 1 over 16. That's the equation that we need in order to solve for the amount of time that Ross takes to mulch the garden, which would be in minutes. Okay, now I'm going to show you one more example. Okay, so water flowing through both a small pipe and a large pipe can fill a water tank in 9 hours. So, small pipe and a large pipe, water tank, 9 hours. Okay, water flowing through the large pipe alone can fill the tank in 17 hours. Okay, write an equation that can be used to find the amount of time in hours which it would take to fill the tank using only the small pipe. Okay, so I'm going to create that table again. So to use that same equation, work equals rate times time. Create nice little boxes. Okay, so water flows through a small and large pipe. Small and large pipe. One water tank. So, oh, I forgot the units. So my units. So my I'll write it on the bottom here. You guys can I think you guys can figure it out. But okay, so my work is going to be the number of tanks. Hours, like we said earlier, is going to be here. And this is going to follow the similar format as this problem. So what we have is the rate is going to be tanks per hour. That's how we find rate. Okay, so we said small and large, so can fill one water tank. One water tank in 9 hours. Water flowing through the large pipe alone. Okay, so large. The large pipe alone can fill the tank. Oops, I forgot that. So here's some important information. So one tank in 17 hours. We need to write an equation that can be used to find the amount of time it would take to fill the tank using only the small pipe. So small pipe will be up here. So we know the small pipe is going to be used to fill the tank, or it could be used to fill up a whole tank, right? So we have one tank here, and we don't know how much time it would take to fill the tank. So time, this is our unknown variable that we would essentially solve for. Okay, so now if we find the rate, we do the same thing. 1 divided by t, 1 divided by 17, 1 divided by 9. Now we can set up our formula. So this means our formula that can be used is going to be 1 over t plus 1 over 17 equals 1 over 9. So these are the expressions. All of these here. These are the ones that can be used to solve for time. And that's good for now. Okay, so in the next part, I'm going to show you the other word problem. A little bit harder. Not that much harder though. Okay, thanks, bye.